It's my pleasure to be here today and to share with you some of the exciting things that I've learned over the last 18 months by putting Watson to work, as I call it. Watson at play was what Jeopardy was. And over the last 18 months, we've been trying to put Watson to work. And I'm not going to talk about it from an IBM perspective, so it's not an IBM commercial. It's more about my own insights about how exciting and how powerful this set of technology is they're already proving out to be and what they would mean for mankind. In fact, I'm so excited about the results that we're seeing. I'm going to share with you that, and also I'm going to draw an arc to show what, if you can extend what we are seeing now, what that might mean for humanity. It is so powerful, in fact, that I consider this to be the most meaningful thing I have done in my professional life. You all probably saw the Jeopardy game. How many of you saw the Jeopardy game? Right, so yeah, we get about a 80% unaided recall on what Watson is. And so the obvious question is, why did it capture our imagination? What's the big deal about Watson? Right? It's this whole notion of computers beginning to understand human speech and human language and learn from human beings. Right? For example, if you ask a computer a question, who ran GE? And unless you have, in the existing computer systems, a database and a table that says CEO and company, that's a very brittle query. Computers can't answer that. What Watson can do is read through, in fact, all of the Wikipedia, most of the world's information we're beginning to put into Watson now. It can read a paragraph like the one you see up there and say, based on my understanding of human semantics and syntactics and synonyms and similes and metaphors, I can deduce that Jack Welch ran GE at this time. Right? It's the beginning of computers that start, what you call as cognitive computing, computers that understand, not just calculate. What's even more interesting is human language, in English in particular, is not the most easiest of languages. So we have things like, noses that run and feet that smell. How does the machine understand that? Feet are supposed to run and noses are supposed to smell. So the computer understands it. Watson understands that. Not only that, it can understand very domain-specific stuff. Now we are teaching Watson medicine, and I'll share with you what some of the exciting things we are finding by putting Watson into medical school. Right? And we are finding that there is a whole new domain of how doctors speak. And Watson is becoming very adept at medicine very fast. In fact, right now we believe it's operating at the level of a first-year medical student. I'll share with you how and why and what the consequences of this is. What is also important about this is that these are computers that are beginning to act and understand on information, not just data. Right? This is the beginning of machines that are information-based, not data-based. And that's particularly relevant now because 90% of the world's information was created in the last 2 years. 90% of humanity's information was created in the last 2 years, and 80% of the 90% is not numbers. It's doctors' notes, call center notes, Amazon reviews, Facebook, tweets, things that today computers can't understand. Watson, by the Jeopardy demonstration, started proving that machines can now start understanding human speech and language and learn as they understand and interact with the machines. With technologies like Watson, humanity now, if you look out 50 years, 100 years, I believe is going to be at a bending of the knowledge curve for humanity because now you're not just capturing the information about people, you're capturing the knowledge about those people, their experiences about people. Watson at the heart does three things. Number one, it understands human speech at scale. It can process the system that played Jeopardy, 200 million pages in 3 seconds. Okay? Can read 200 million pages, understand the meaning of those 200 million pages in 3 seconds. Second, it generates an answer for you with a confidence level. If you ask Watson a question, what is the initial dosage of antibiotics for a 7-year-old child with a history of asthma? Right? Google will give you 3 million pages with keywords on it. Watson will come back and say 3 teaspoons 2 times a day, 82% confidence. And here are 42 sources why I say that. And some of these sources, I know that asthma goes by 7 other medical names, and I pulled all of that for you. Okay? So it's the beginning of what I call as probabilistic applications. Applications that can give you a confidence level, not a deterministic application. They're saying yes or no. And then last but not the least, it learns from the response you select. We believe that Watson is going to, in time, change. If I look ahead in 2020, the way medicine is researched, medicine is practiced, and medicine is taught. Cleveland Clinic, after we did Jeopardy, I challenged the Watson team and I said, let's now take Watson to the next level. Let's make Watson pass the US medical licensing exam, the US board exam. After they stopped throwing darts at me and bringing out some other things, I said, you know what? We are going to try and see how far we go. And here's the interesting part. In 18 months, we are within striking distance of making Watson pass the US medical licensing exam. Okay, we've taken the practice test. Now, these are non-image based yet, and we are finding accuracies that are within reach of making this machine pass the US medical licensing exam. Just imagine the power and the possibilities. So as you fast forward this, you can only imagine implications of a technology like this. Okay, healthcare, the only $2 trillion industry that we have, right? $1.8 trillion, 18% of the US GDP, full of problems, right? You can look at this in financial services. If I'm a bond trader, if I'm a hedge fund manager, I have to read through 100 different treasury bonds and prospectus on municipal bonds. Every one of them is a 200-page document and create a portfolio. It could change how I make decisions and investments. Contact centers, every call center in the world could use a Watson. One of the things we have done, and we're announcing this next month, but we've started talking about it already, is this notion of a baby Watson. The system that I inherited with a game playing Jeopardy was the size of a master bedroom. And as you heard, I live in Austin, and in Texas they have pretty big master bedrooms. We have reduced that master bedroom size machine down to a one server machine now, okay, in the last 18 months. It's 9 inches high, 18 inches wide, 36 inches deep. It weighs about 100 pounds. We call it a baby Watson. And it's 240% faster than the machine that played Jeopardy, pound for pound. There are some major technology forces that are converging in this industry. Things like mobile. Everyone's shifting from the PCs to smartphones and tablets. Things like cloud computing. So people call it the hand to cloud and back. That's how we're going to work, right? Things like big data. This is data coming. It is, like I said, 90% created in the last 2 years, doubling every 5 years. Things like social, where people are sharing more and more information in text and other information about us. Analytics. And then millennials. People who expect to interact with systems very different than how most of us in our 40s or beyond tend to look at. So when you start looking at the convergence of this and a technology like Watson, I think it's going to be a fun 3 to 5 years in the IT industry. It's shifting from calculating rapidly to learning from data and interactions. One of the things I like to say is, in 5 years, we'll look back and say that machines before Watson were nothing but giant calculators. Computers after Watson were cognitive systems that understood us and interacted with us and start helping us make decisions. So with that, again, I want to thank you for the opportunity and watch this space for a lot more exciting things coming our way. Thank you.